Welcome to BISTRA Tutorials. You can find the corresponding exercise files to download from the link mentioned in the description of the video. In this first tutorial, you will learn a few basic tools and understand the interface. You can start a new project either from a BISCO file or a bitmap. From the File menu, click on Open Bitmap and choose the bitmap file, then click on OK. We now see the bitmap's geometry loaded into BISTRA with properties at the color window linked to the default color database. Now we explore an alternative method. From the File menu, click on Open, then you are asked if you want to save the existing project before you open a new file. Choose No. Now change to BISCO data files from the drop-down list and then select the file to load. The benefit of this workflow is if you modify properties at the color window locally for the BISCO project, for example, assign split cavities, those changes are reflected now in the BISTRA project. While this is not possible while loading a bitmap directly to BISTRA, as it reads only default properties from the color database. Upon opening, you see the three main windows in BISTRA: bitmap, measures and colors. The user interface is very similar to BISCO. However, as BISTRA deals with dynamic simulations and includes a solar processor, the color window now includes additional parameters: density, specific heat, sun, solar reflection, specularity and solar transmission. We shall discuss these in detail in the next tutorials. As in BISCO, the geometry is defined by a bitmap which can be altered from the measure window. At BISTRA we define a material or boundary condition using a color which is assigned to each pixel. We can input the color from the default Physibel color database or customize the color to alter the properties of material or boundary conditions. You can use the scroll wheel to zoom. If you click on any pixel on the bitmap window, the corresponding color assigned is highlighted at the color window and geometric dimensions are highlighted at the measures window. In this example, we have an externally insulated concrete wall placed under an outdoor temperature of 0 degrees and an internal temperature of 20 degrees. The conductivity of the insulation and the wall are 0.04 and 1.8 watts per meter Kelvin respectively. Here boundary conditions are defined using type BC simple and materials under type material. We will talk about these later under the BISTRA colors tutorial. At the measure window, you can alter the dimensions of the geometry. For the concrete wall represented with color 120, there are 40 pixels along the width and 200 pixels along the height. On top, you see the width and height of each pixel and they are linked to each other to maintain the geometric shape. Each pixel is 5 mm, so we have a wall of width of 5 mm multiplied by 40 pixels, which is 200 mm. Suppose you change the pixel width to 10 mm, and you notice pixel height also automatically updates. Now the width of the wall changes to 400 mm. We change the pixel size back to 5 mm. For insulation with color 131, there are 20 pixels in total along the width and 200 pixels along the height. Since the width of each pixel is 5 mm, the total width of color 131 is 20 multiplied by 5 mm, which is 100 mm. Now if we want this dimension to be 0.15 meters, we input this value and notice pixel size changes and the dimensions of the rest of the geometry also updates automatically. So at the measure window, you have the freedom to scale at the level of pixel or at the level of geometry. We change back the width of the insulation to 0.1 meters. We need to triangulate the grid to perform analysis. Here we say that one side of the triangles is 2 pixels. You can choose to make a particular color having finer mesh using a lower triangulation size if required, but this would also imply having a higher number of calculation nodes and thus a longer simulation time. We can first perform analysis with these settings to visualize the resulting mesh. We first set the calculation parameters. You can click on the icon at the top toolbar or choose it from the Edit menu. Here we define the time step between each calculation. Say we calculate for every 5 minutes. In this tutorial we have not defined any dynamic or parameters changing with time yet, so we restrict only a few calculations as it would perform repetitive calculations with static parameters. Hence we input the calculation duration as 15 minutes. You can now close this window. From the Calculate menu, choose Save Frequency. By default this is set to off, turn this on by clicking Yes. Now this would create solution files for each time step so you can later visualize the result in graphic output. We now can click on the Calculate system and choose Yes for recalculation. Then the software performs the calculation for analysis time, which is 15 minutes. To visualize the result, click on Graphic Output and choose Fill Temperatures. To visualize the analysis mesh, click on Triangulate. You can now close the graphic output. By default, the color window is under List Present, which means only the colors which are defined in this project are displayed here. From the Colors menu, choose List All. Then we see all the 256 colors from the Physibel color database. If you choose List Defined, you can only see colors with predefined properties, and colors which are used in this project are in editable format. You can update the existing applied color by selecting the color you want to change, and from the Bitmap menu, choose Change Color. Here you can enter the new color number you wanted it to update with. You can modify the bitmap using the functions Draw, Line and Rectangle. Suppose we wanted to add a sensor using a pixel in the center of the concrete wall. We first change the color window to List All and then choose the color we have not used, say color 20. We choose the Draw tool and click in the middle of geometry. We now change the colors window back to the list present and see the additional material created for the sensor in this list. We update the color properties of the sensor same as that of the concrete. Thank you for watching, see you in the next tutorial.